Hello everyone, and welcome back to the Fluctus Channel. For fighter pilots, even the simple problem of carrying luggage turns into an aviation challenge. A single-seat fighter, like the F-16, is built around fuel, avionics, weapon stations, and survival equipment, not around storage space. There is barely enough room in the cockpit for maps, checklists, emergency gear, and the pilot's body, let alone a proper travel bag. Yet military aviators still have to move between bases, carry personal equipment, and bring essential items with them when they deploy or reposition. One of the cheapest and smartest solutions the Air Force found was the travel pod, a streamlined external cargo pod mounted beneath the jet. In simple terms, it acts like a small trunk for an aircraft that otherwise has no trunk at all. Instead of needing a support aircraft or a separate baggage plan for every short movement, the pilot can fly the jet and carry the basics in one trip. That is why the travel pod became such a useful piece of everyday fighter logistics.
So what we use these for is to obviously travel. We throw our stuff in here. This is going to be for the pilot stuff, and then we always throw the maintenance stuff on this side. Same exact pod, we just put them on different sides, store different things in them.
It is inexpensive, reusable, easy to load, and practical enough to solve a routine problem without changing the jet's core mission. The pod does not turn a fighter into a cargo plane, but it gives the pilot just enough capacity to carry luggage, tools, clothing, and small mission essentials while keeping the aircraft self-contained. For a fast-moving fighter force, that matters. It saves time, cuts down on support requirements, and allows pilots to arrive with what they need without creating a larger transport operation around a very small amount of gear. In military aviation, those kinds of simple solutions often matter more than people realize. But before any luggage flies, the pilot's real focus is always the aircraft itself. A fighter pilot does not simply walk to the ladder, strap in, and launch. The routine begins with a deliberate inspection around the jet. The pilot studies the landing gear, the tires, the intake, the wings, the panels, and the store stations, making sure the aircraft looks exactly the way it should before flight. On a single-seat fighter, there is no second crew member in the cockpit to help manage a hidden problem once the aircraft is airborne. So the pilot has to trust the machine completely before leaving the ground. That is why even a small irregularity matters. A latch that looks wrong, a panel that sits unevenly, or a stain under the fuselage can change the whole tone of the pre-flight. Fighter pilots learn to read the jet visually before they ever power it up. Sometimes the routine becomes almost personal. A pilot may wipe down the canopy by hand, not because it looks untidy, but because clear visibility matters in formation flying, air combat maneuvering, landing, and simple situational awareness. Around the aircraft, maintainers and pilots also rely on a silent language of hand signals and practice gestures. When engines are running and the flight line is full of noise, spoken instructions are unreliable. Signals guide engine start, safety checks, movement around the jet, and taxi preparation. That nonverbal coordination is part of the discipline that keeps fighters safe on the ground. So, while the travel pod may be the cheap answer to the luggage problem, the larger fighter routine is built on something much more serious. Inspection, trust, repetition, and a professional understanding that even an ordinary ferry flight begins with combat-level discipline and ends only when the pilot and the aircraft return in the same condition they left. It is built to catch trouble early and preserve confidence before flight. That same idea becomes easier to understand when you look beyond fighters and watch what happens on a civilian airport apron. The apron is where aircraft park, board passengers, receive fuel, load baggage, unload cargo, connect services, push back, and begin taxiing. From the terminal, it can look routine, even calm. On the ground, it is one of the busiest and most tightly managed environments in aviation. Ground crews, baggage handlers, fuel trucks, belt loaders, tugs, and marshalers all move around aircraft according to timing, spacing, and strict safety procedures. Every bag that goes into the hold, every container that is aligned at the cargo door, and every signal exchanged beside the nose wheel is part of a carefully controlled process designed to get the aircraft away from the gate safely and on time. The apron is not just a parking area. It is a working zone built around machines that can injure people or destroy equipment in seconds if the procedures begin to break down. That is why the area depends so heavily on markings, protective gear, cones, vehicles placed in exact positions, and workers who understand where the danger zones begin before the engines are even started. That discipline becomes even more important during turnarounds, when several aircraft may be loading, fueling, and preparing to taxi at the same time. Each surrounded by vehicles, workers, and deadlines that leave very little room for hesitation. One of the biggest dangers on the apron is engine ingestion. A running jet engine does not only push air out the back, it also pulls air in at great force through the intake. That means loose baggage, tools, plastic, paper, safety cones, and even parts of service equipment can be dragged toward the engine if they enter the wrong zone. Something that looks harmless sitting on the ramp can become a destructive projectile in seconds. This is why foreign object debris, or FOD, is treated as a constant threat in airport operations. Workers have to think not only about what is in their hands, but about what is on the ground, what is rolling nearby, and what could shift when the airflow around the aircraft changes always. To reduce those risks, apron work depends on layers of precaution. Workers approach aircraft only at the right time. Stay clear of intake and exhaust zones, secure loose gear, and use hearing protection. High visibility clothing, painted safety lines, and marshalling procedures to control movement. Another smart solution appears when the engines are not running. Intake covers. These simple covers protect the engine from birds, dust, and debris while the aircraft is parked, helping prevent unnecessary damage before the flight even begins. Jet blast creates another hazard. The exhaust from a powerful aircraft can knock people over, flip equipment, send debris across the ramp, and damage nearby vehicles. Airports therefore rely on blast fences, designated engine run-up areas, and careful aircraft positioning to shield workers and machinery from the power of the exhaust. None of these safety measures looks glamorous, but that is exactly the point. Aviation on the ground often depends on low-cost, practical barriers placed in the right spot at the right time. They do not attract attention when they work, but they prevent the kinds of accidents that turn routine apron operations into emergencies. In that sense, the apron reveals an important truth about aviation as a whole. Powerful aircraft may dominate the headlines, but everyday safety is usually protected by simple procedures, cheap protective devices, and workers disciplined enough to treat familiar tasks as if they still carry real danger every single day. That safety mindset becomes even more intense on the flight deck of an aircraft carrier, where the working space is smaller, the noise is greater, and the margin for error is even lower. Here, jets launch at high power only a short distance from deck crews, parked aircraft, tie-down chains, ordnance, and the edge of the sea itself. One of the most important safety devices in this environment is the jet blast deflector. Raised behind an aircraft preparing to launch, it shields personnel and nearby equipment from the intense exhaust. Without it, the blast from a carrier-based jet could hurl loose gear across the deck and seriously injure crew members standing nearby. Safety on the flight deck also depends on precise hand signals. Aircraft directors use a standardized visual language to communicate engine status, taxi instructions, launch readiness, and emergency cues, because spoken words disappear in the roar of engines, wind, and deck machinery. Every movement of the hands has to be understood instantly. Just like on an airport apron, foreign object debris remains a constant threat. That is why flight deck crews conduct FOD walks, scanning the deck for bolts, scraps, hardware, and anything else that could be sucked into an engine or blown across the launch area. Blowdown operations add another layer of protection by clearing debris from the deck before flying resumes. These may look like basic housekeeping routines, but they exist because intake hazards are brutally real. Naval aviation has long remembered the case of a crewman who was pulled into the intake of a running aircraft engine and survived only because the pilot reacted quickly enough to shut the engine down. The lesson was unmistakable. Around a live intake, even a trained deck crew member can be in danger in an instant. That is why intake screens and protective covers remain such important tools between launches. Crews can fit covers over parked aircraft intakes to reduce the risk of debris ingestion, while chains, ordnance, carts, and support equipment continue moving around the deck. Newer innovations have pushed that idea further with portable magnetic aircraft covers and other quick-fit protective devices designed to make the process faster and easier. On a carrier, the safest tool is often the simplest one laid out before the next launch cycle begins again. In the end, whether it is a travel pod helping a fighter pilot carry luggage, an intake cover protecting a parked engine, a blast fence shielding apron workers, or a jet blast deflector protecting a carrier crew, the larger lesson is the same. Military aviation often looks like it's defined by speed, noise, and power. But its daily success depends just as much on simple, clever solutions that quietly reduce risk and solve practical problems. Small tools and basic procedures keep aircraft usable, crews safer, and operations moving. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.